Testing. Testing.
Testing.
Okay, so I will begin the lecture now early. So before we go on further for the next part, I would like to refer to chapter 9 for the fourth lectures regards on cumulative distribution functions, example number 2 that we have missed out the other day, where this example is happen to be more complicated than example 1. And for this video, I will write down the step in details rather than what we have did in the lecture hall. I just happen to show you the guideline and then I remain the rest of the parts complete by you. And also later when the time I do for these questions here for cumulative, I will do the shortcuts way to get the answer. Okay, let's see. Example number 2. A continuous random variable x has probability density functions given as fx equals to x over 16 for from 0 until 2, include 0, not include 2, 1 over 8 from 2 to 9, include 2, not include 9, and otherwise is 0. Then we want to obtain the cumulative distribution functions here. So in order to get these questions here done, first of all, I would like to advise you that as a beginner, when the time you want to find the cumulative functions, I suggest that you turn all the functions, the whole function there, all the x terms, we're going to turn in terms of t. So I have t over 16, 0 less than equals to t less than 2, 1 over 8, 2 less than equals to t less than 9, and then 0 for otherwise. 1 over 8 and 0 don't seem to have any changes because they happen to be constant functions. Okay. This is not a compulsory step. If you can happen to have this in your mind, then it's all right to don't write it down. Okay. The next thing is that I would like you to refer to the interval, the value that you can see. So you can see that we have 0, we have 2, we have 9. So this value here is happen to be the border value for number line, which means that we draw a number line as a guideline and we need to mark down the value 0, mark down the value 9, and also mark down the value, it's supposed to be 2 here. Mark down the value 2, mark out the value 9. So this is happen to help us to see the result that we obtain later for our cumulative will happens to have how many interval and how many interval we need to consider. So we have 1, 2, 3, 4 interval. Then when the time we consider our cumulative, we happen to accumulate from negative infinity until somewhere in the first interval, somewhere in the second. So first, second, third, and fourth. From negative infinity, stop somewhere in the first, stop somewhere in the second, stop somewhere in the third, and also stop somewhere in the fourth. And for example, if I happen to be from negative infinity, stop somewhere at the first interval, it can be just on the spot of 0 or any place before 0. So let's say I put a place before 0. So here I need to consider the interval as x less than 0. If I happen to stop somewhere here in the second interval, then I need to consider for, so for the second interval, more or less like what you happen to have in the questions here, you just copy it back. So we have 0 less than equals to x less than 2. The third one, 2 less than equals to x less than 9. And last one, x greater equals to 9. And please be aware, in your inequality sign, you see the border value 0. For example, only one of the side we put the equal, and which one how we should decide is that depends on the original PDF we have, where the equal is relocated at where. So the next one you happen to see that the 2, the equal sign. Also, we write according to the questions. Okay. Anyway, if you happen to have problem to remember this, then just for simplicity, you always put your inequality in this formula. Equal in front, less than behind, no matter what situation, just for simplicity. Okay, now we begin our solutions. So I consider, let's say I want to find the cumulative for the case that for the first interval. Let's say I travel from negative infinity, stop somewhere in the first interval, where my x stop at x less than 0. So the cumulative will happen to be fx equals to integrate negative infinity until the value here, please take notes, we don't write 0, but we write x. And the corresponding function we're going to use is that, so guys and girls, if you notice, the function we're going to use for the first interval here is 0 because it's located in otherwise. So we will substitute integrate 0 and then dt. Don't forget, we are integrating with respect to t. The function here is regard on t. So integrate 0, the answer will just 0. And once again, I want you to be aware where this part here, where this part here, the upper bound of your integral is happen to be x for the first one. You may not see the difference in the first case is because whether this is x or you put it as some other value according to the interval, it still produces the answer as 0. But I need you to be aware of it. Then next, let's say now I happen to travel from negative infinity until the second interval. So if I happen to have my x drop at the second interval, so according to what we know is that we have at 0 less than equals to x less than 2. So your fx, your equals to, so guys and girls in here, I just want to go straight to the shortcut, where be aware of the shortcuts. What I will do for the shortcuts here is that instead of having integrate from negative infinity, I just consider the integrate from negative infinity to become a cumulative f of something plus with integrate dt. And what is the thing that we have here is that, please be aware, I will consider the smallest value in this interval. So the smallest value of this interval will happen to be 0. So I will have it as f0 plus integrate 0 to x. I don't stop at 2 because my value of this integral here is stopped somewhere in this interval. If I put 2, that means that for sure I must fix myself, stop at 2. But that is not what we want. We want to stop somewhere in this interval. That's why we put x. And the function involved here is that you refer to the interval, or the second parts. What we happen to have referred here is that if right in terms of t, we are referring to t over 16. T over 16. So the part here, we will have it as t over 16. So therefore, the functions we have here inside it will be t over 16. Go on. The next part, please be aware. How we happen to calculate the cumulative here is that the cumulative functions, we are going to calculate based on substitute 0 in the previous function. So the previous cumulative function gives us fx equal to 0, which is a constant function, which means that if you refer to the previous constant function, no matter what you substitute inside the x, it will always produce 0 for us. So as a result, I have it as 0. Then the integrate, we proceed the calculations. So we integrate, we happen to have the answer as t squared over 32, just a simple integrations. Then as a result, The 0, we can just ignore. We focus on the calculation of the integrations here. So if I substitute x inside, I have x squared over 32. When the time I substitute 0 inside, by right, I have minus 0. And maybe, just for simplicity, this part here we just ignore. It will just x squared over 32. Okay, proceed. So this is when the time my cumulative stop at the second interval. What if now, if let's say I happen to have my cumulative all the way from negative infinity until the third interval, somewhere in the third interval, which is from 0 to 9. So now, proceed further. So let's say I continue the calculations at below. So we will have the calculations for the case of 4, 2 to 9, for 2 to 9, include 2, not include 9. So how we happen to have our cumulative here is referring to fx equals to, so I will have f, a capital F, plus an integral. Integral is with respect to t. Then from where to where we should go for the integral, and what should we fill in the blank here for the f. So again, the key is that, the clue is that we refer to the smallest value that we have in the interval. So therefore, I will have it as f2, smallest value 2, from 2 until x. And what's the functions that we happen to involve here is that, if refer to the third interval, the functions that we involve, it will refer to 1 over 8, which will corresponding to this part here. So proceed. Now we put in our functions, 1 over 8. Continue. So f2, how we happen to calculate the f2 here is that, again, the f2 is calculated based on substituting 2 into the previous cumulative. So as a result, what we have is that we will have 2 squared over 32 plus with integrate 1 over 8, you have 1 over 8 t. Again, don't forget our function here regards on t. We integrate with respect to t. So from 2 to x. 2 squared over 32, when the time I happens to simplify it, I have 1 over 8. Plus with the other side, when the time I substitute x inside, I will have 1 over 8x minus, substitute 2 inside, I have it as 1 over 4. And as a result, when the time you further simplify, we have 1 over 8x minus 1 over 8. So there goes my third interval function. And then lastly, we have our last interval. If let's say from infinity until the last interval, which corresponding to my x value happens to be greater or equal to 9. The last part here, x greater equals to 9. And let's see what we will obtain. So proceed. How we calculate for this cumulative here is that, again, we have fx equals to f bracket plus an integral dt. What is the value we shall use now? Similar concept like just now. Refer to this interval, what is happen to be the smallest value. And be aware, in these questions here, if you refer to interval form, you shall see that the smallest value will refer to 9. It will refer to 9. So when the time I consider for my calculations, it will be f9, and from 9 until x. Again, I will integrate the upper limit. You find out that it is always happen to refer to x here. And the functions is happen to be 0. Why is happen to be 0 is because if you refer, this part is referred to otherwise. Greater than 9 in the definitions here is otherwise. And proceed further for our calculations. What we happen to have here now is that f9, what we do for f9 is that we substitute 9 into the previous cumulative. So what I have now is that 9 over 8 minus 1 over 8. The integral here turned out become 0. So as a result, I have the answer equals to 1. And once I finish these calculations here, it is not end of the story yet because I need to state down what is my cumulative functions. So now as a result, my cumulative functions, capital Fx. So based on our calculation later, you notice that we happen to have 4 parts, where the first part is that we have our x less than 0, and this is defined by 0. The second part, you find out that the interval we involve for x is x less than equals to 0 is less than equals to x less than 2. And this is being defined by x squared over 32 in our previous calculation. Third interval from 2 until 9, but exclude 9. So we have 1 over 8 x minus 1 over 8. And lastly, 1 for x greater equals to 9. So this is the cumulative functions that we happen to have here for the answer part A. Okay. So once I get my cumulative functions, then I proceed for the next part, part B. They ask us to sketch the graph of capital F. So in this case here, basically what we need to do is that we're going to sketch the piecewise function of this capital F here. So how we happen to sketch here is that, let me show you the strategy, then I show you the full diagram in a better better drawing. So I will recommend that you start from your x-axis first. Y-axis maybe later we refer. So why I want you to start your x-axis here first, so that you know your border, you happen to refer to from where to where, and make it an exact skew. For example, you happen to have 2 cm for 2 units, 9 cm for 9 units. Then you see that you happen to need to consider 3 interval here. And for the 3 interval, you sketch your corresponding graph. So the first one, 0 for less than 0. That means that you need to use your ruler to have a flat horizontal line for this part here, less than 0. Followed by a quadratic x squared over 32. So quadratic, it will happen to be something like this, a quadratic curve. And of course, you need to find out what is happen to be the value of this point here. So when the time you substitute 2 inside, I find out that this part here will happen to be have the height of 1 over 8. Here is the point 2, 1 over 8. Then follow, we have the line, a straight line, 1 over 8x minus 1 over 8. So we continue with the straight line. And by right at this point here, you happen to find out that you have 9, 1. And then lastly, it will happen to be a horizontal line. And the result in a better diagram will happen to look something like this. So as you can see now, where this is something that I mentioned, This is the part for less than 0, the quadratic curve. Quadratic curve. Quadratic curve. The straight line. And then the flat line at 1. And you find out the graph is happen to be continuous. And I want to mention the word continuous, where you happen to see at this border value here, when x equals to 9, whether you substitute in the third functions or the fourth functions in your cumulative, they will happen to produce you the same value of y in terms of graph here. Okay, go on. Now we proceed our calculation for the next part. What we want to find out here, we would like to find out what is happen to be px greater than 1 and also px less than equals to 5. And in this case here, let us make use of the cumulative function that we have find out so that our work will be simpler. So in here, what I will do the next is that let me extract the cumulative functions for reference later. So let me copy now this one. This is the answer for our cumulative functions. Okay. So what are the things that we want to find out now is that, let's see. According to the questions, part C, these are the things that we would like to find out. Okay, hold on. It hang. Okay, so these are the things that we want to find out. And let us try to solve these questions here. So part C, we would like to find out what is px greater than 1. And let's say now I want to make use of cumulative only for calculation. So how we happen to get this answer here? So listen carefully on the explanation. First of all, recall on the idea of cumulative. Whenever you write something like this, let's say FA, what is happened to means for both the case of cumulative and also the case of discrete, it is always referred to px less than or equals to a. And if I want to make use of my f capital functions f to solve this, the capital F functions to solve this, I need to refer to something less than equal. And let's have a quick look. If greater than 1, that means 1 is here. Here is greater than 1. And what I'm interested now is that I want to find x greater than 1, but I need to make use of the information of x less than equals to 1. And from the diagram, you somehow can see that the shaded region is the one that we want. The one not shaded is the one that we don't want. And both of them together is overall. And you can see now, the part you want is actually overall 1 minus the part that you don't want. And the part you don't want is actually referred to the cumulative F1. And to solve cumulative F1, what you need to refer is that refer to the piecewise function for capital F. Let's see where is the location for x equals to 1. You find out x equals to 1 in the second function here, the second interval here. And therefore, now we go for our calculation. We substitute 1 into the second function. So as a result, I have 31 over 32 for the first answer. Continue. For the next case, if I want 1 less than equals to x less than 5, how I happen to calculate for this case here. So take notes, guys and girls. In the case that you have something like this, where it happens to be a interval, something like this, from an integer, from a value, from a fixed value to another, then we can make use of the calculations in such that, for example, my FB, let's say FB minus FA is happen to be defined equals to P. Okay, take notes. This formula I written on top up here is meant for both discrete and continuous. So if it happen to be A less than or less than equals to B, this is for both discrete random variable as well as continuous random variable. Okay, so but the question I want now is not one less than equal, it's not one less than x and less than equals to 5, but instead you see the sign, it's not the same as what we have to define with fb minus fa. But remember, in continuous random variable, let me write a remark there in red. For CRV, continuous random variable, you find out that A less than x less than equals to b is the same for P A less than equal x less than b. No matter how you manipulate the equal sign in the inequalities here, they are referring to the same thing in continuous random variable. They are referring to the same thing for continuous random variable. So in this case here, I can just happen to make it as simple as f5 minus f1. f5 minus f1. And the remark here is that, so to relate with the questions, let me rewrite this one here, relate to our questions. So for continuous random variable, you happen to find out that your P1 less than equals to x less than 5 is the same as P1 less than x less than equals to 5, which is defined as f5 minus f1 in general. Okay, once we clear about this thing here, f5 minus f1, how we happen to calculate. So again, let me extract these equations here. Let me extract these equations here to the other side so that I can refer it for my calculations. So let's see. First of all, I want f5. f5, let's see where is the part that we have x equals to 5. You find out that it's in the third functions. So therefore now I substitute my f5 with 5 over 8 minus 1 over 8. So this is for f5. And then it will follow by minus my f1. So in here, my f1 will happens to refer to the second functions. So I substitute, I will happen to have it as 1 squared over 32. So this is referred to the second function. Then as a result of our calculation, when the time you happen to simplify your answer here, you have 4 over 8 minus 1 over 32, and this will give us the answer. This will give us the answer as 1 over 2 minus 1 over 32, and as a result, I have it as 15 over 32. There goes your answer. Okay, go on. The last part D. What we want to do is that we want to find out the median. So guys and girls, so these questions we already have the cumulative. So we just make use of the cumulative functions to get the answer. We don't have to go through the process of integrate anymore. So let's see. Again, I drag down this function for reference to solve for part D. How it happens to find the median for this case here, guys and girls? So by the time you find out that if the functions that we have, whether is cumulative or the PDF, if there is happen to be more than one non-zero functions like this, then we need to investigate whether my median is located in which interval. Median, we know, recall, median M is occur when the time I have my FM is equals to 0.5. If I want to discuss for the case of cumulative. So from this function here, you can see beginning with 0 and with 1. So 0.5 will be somewhere between the second one and the third one. But which one is that? So we need to start with the investigation of the location first. So how we investigate for the location is that we're going to begin with the next interval, the function of the next interval. After we have fx equals to 0, what we do is that we substitute the largest possible x you can see into the functions. Even though there is no equal sign, it doesn't matter. We have calculate f2, substitute the 2 inside here for the calculation. We find out that we have 2 squared over 32. And let's see how much we have here. By the time we have 2 squared over 32 in our calculations. So you find out that your answer is happen to be 1 over 8. And what is this 1 over 8 try to tell us is that 1 over 8 you find out is less than 0.5. So if it happen to be less than 0.5, that means this region here does not have enough coverage to get the median. Therefore, it happens to indicate that the median does not lie on, so it does not lie on the interval of from 0 to 2. If it doesn't lie on 0 to 2, then the remaining choice we have here, if we're only left with the third interval. This one saja lah. Tak mungkin the last one, because last one f is already equals to 1. So therefore, from there, we can proceed with our calculation of Fm equals to 0.5. And where we say M is happen to be the median. So now we're going to substitute Fn into, so be aware, we're going to substitute Fn into the third functions, x over 8 minus 1 over 8. So what we have here is that we have x over 8 minus 1 over 8 equals to 0.5. By the time I multiply 8 on the whole thing, and I find out x is equals to 5. Sorry, I make a mistake here, sorry. By right, it should not be x anymore. It should be m. It should be m. So please take note, it should be m here. And this produces us the result that, therefore, the median is equals to 5. So this is how we happen to solve for the case of example number 2 in continuous random variable. Okay. Next, we go for the last part of the lecture of chapter 9, where we want to discuss the expected value and the variance. So guys and girls, just have a quick look on the idea here of the calculations of the expected value and also the variance. So these are the formulas that I happen to summarize that you need to take notes. Where, first one, the way to calculate for continuous random variable for the expected value, EX, or this one, sometimes we just call it as the mean or the mu, is integrate from negative infinity until infinity for x multiply the function fx. More or less like what we have in the discrete case, but the discrete case, we have the case of summation instead of integration. And once again, the infinity try to tell you that later in your calculation, you just need to start from the smallest and largest x value that you can see in the functions. If you have ex squared, similar thing, just that now the function become x squared. Also integrate from the smallest to largest. Variance basically is the same formula as you do in the discrete case, where we have expected value of x squared minus the square of ex. And further also, we will go through by some properties of the calculations of expected value and variance as follow. If a and b is happen to be constant, so eax plus b equals to, as if like we factorize out the a, we bring out the plus b. For variance, the plus b, we ignore it because variance for b is always equal to 0. For the coefficient of x, we bring it out and then we square it. And we'll see further in our examples later. Okay, once you're done with that, let us have a look on our solutions now. Example 1. So I will spend some time in writing the solutions. Of course, I have a better typing one. But now let us see step by step for the calculations. So example 1. This example is a bit tough because we start with a PDF with more than one non-zero function. So please be aware on how to solve for this case here. Okay. Now I will proceed further for the solution. So please have a look. You're given this function fx. Now I want to get my ex. So how I happen to get my answer? Let's see, guys and girls. Part 1. I just write at the side here. My ex will happens to be equals to integrate x multiply with my function fx multiply with this PDF. So that means each of this that you see, you're going to multiply x later. And from where to where we should do integration is that from the functions, you happen to see smallest is -1, largest is 1. So this is the one that we want to have for the answer. Of course, in general, we just write infinity to infinity. But let's say we have specific case, we just refer to the largest and smallest x value we can see for the non-zero function. Okay, go on. By the way, the first line I highlighted in pink here is not a compulsory step. It's just the introductions, how we calculate for the expected value. Now we refer to the functions and we're going to grab for our answer. So our ex is equals to, so when the time we want to integrate from -1 until 1, you happen to see that we will happen to pass through two functions, where from -1 until 0, we're going to consider the constant function 1/5 plus from 0 to 1, I have 1/5 plus 6/5x dx. So again, to identify that, you can make use of a number line. We have -1, 0, 1. When the time you want to integrate from -1 to 1, you happen to pass through two functions, two interval, involved of two functions. So we need to split into two integrals. And take notes, this solution here is not the correct solution because what I substitute now is 1/5 and 1/5 plus 6/5x is just the function fx itself. By right, what I need is that, okay, let me again extract out these equations here. to show you the things that I actually need. Okay, guys and girls, what I need now is that I don't want the fx, I want x multiplied with fx. In other words, so again, let me extract out. What I actually need is that I need the function fx, I multiply with x. So as a result, this one will be 1 over 5x, 1 over 5x, and 6 over 5x squared. This is the one that I want to substitute in for my calculation. Therefore, now I need to edit my answer. So please be aware, it's x multiplied function of fx. So as a result, I have, let's say just write it as x over 5 plus 6x squared over 5 dx. So these happen to be x multiplied fx. By the time I integrate my result, so I will have it as x squared over 10 from -1 until 0. The other one, x squared over 10 plus with 2x power of 3 over 5 from 0 to 1. So this is the initial result when the time I happen to complete my integrations. And next, what I'm going to do is that I'm going to substitute the value. I'm going to substitute the value accordingly. So please see carefully on the calculations. By the time I substitute 0 inside x squared over 10, I get 0. I substitute -1 inside, I need to minus. By the time I substitute -1 inside, I will have it as 1 over 10. Plus with, for the other function, when the time I substitute 1 inside for this function here, if you have a quick calculation, you find out that you have 1 over 10 plus 2 over 5. So 1 over 10 plus 2 over 5, if it happens to give us the result equals to 1 over 2. 1 over 2. Substitute 0 minus with, substitute 0 inside the functions, we have the answer as 0. So as a result, when the time you simplify both sides of the answer, you have the result as -1 over 10 plus 1 over 2, which is happen to give me the answer equals to 2 over 5, or we just write it as decimal 0.4. So again, the answer is 2 over 5, or just we rather write down decimal 0.4. I can just convert into decimal in this case here because 0.4 is the exact answer. So from here, I happen to have my value of my EX. So this is the part 1 answer. Okay, go on. Now I want to go for the part 2 answer, the variance. So again, I need this function here. Let me drag this function down for reference at the bottom. So guys and girls, again, have a quick review. By the time you want to find variance, no matter it's the discrete or continuous case, the variance is always defined in the way of expected value for x squared minus the square of EX. So for this question here, EX I already have the result. Now I need the EX squared. So in order to get the EX squared, what I need to do now is that the thing that I need to consider is that I want to have my EX squared equals to integrate from -1 to 1 for this case here. Again, the smallest and the largest x you can see, -1 to 1. Now this time I want x squared multiplied with fx. I want to have my fx multiplied with x squared. So in other words, instead of having fx, I want multiply with x squared, and therefore as a result here is x squared, x power of 3. So let me write in the functions now. So ex squared equals to, for the interval from -1 to 0, I will have 1 over 5 x squared plus with, from 0 to 1, it will be x squared over 5 plus 6x cubed over 5 dx. And now for the first part of the integral, by the time I integrate, I have x power of 3 over 15 from -1 until 0 plus with x cubed over 15 plus, so here I suppose I have it as x power of 4 3 over 10 from 0 until 1. Then go on. By the time I substitute 0 into the functions, we happen to find out that I have the answer equal to 0. Then I need to minus with, by the time I substitute -1 inside the functions, we happen to find out that I have -1 over 15. Plus with, what happened in the next integral? If I substitute 1 inside this function here, you will happen to find out that I have 1 over 15 plus 3 over 10. So as a result, I have 11 over 30, then minus 0. And as a result, by the time I simplify both of the integral result, I have it as 1 over 15 plus 11 over 30. And this gives me 13 over 30 as answer. 13 over 30 as answer. But please be aware, this is not the answer. This is not the answer for the variance. We haven't reached the answer for variance. Remind yourself, this is actually just ex squared that we're calculating. To find the variance, if it happens to be equals to the ex squared minus the square of the expected value. So as a result, you have 13 over 30 minus the square of the expected value. Just now we get this as 0.4. And the answer, we keep it in fraction form, 41 over 150. You're not recommended to keep it in decimal. If let's say the decimal is not an exact value, if the decimal is something that you need to round off, you're not recommended to keep that. But instead, we keep in fraction because this answer will be more accurate. Then part 3, we would like to find out the expected value of 3 minus 7x. 3 minus 7x. So how we get this answer here? So by properties, just now we happen to see the constant we can extract out. The coefficient for the x inside, we can factorize out from the ex. This is what happened. Have a quick look. Of course, we actually can do the calculation slowly, one by one, where we happen to start with, okay, let's have a look. If let's say you want to do it as a beginner level, we happen to split the bracket terms inside in such that I split it into so we have it as E3 minus E7x. The expected value of a constant will just concentrate itself. Coefficient for the x, I can just factorize it out. But now in my solution, I just go for the express way. And now continue. Based on the previous calculation, you find out that your expected value, just now we find out is 0.4. So based on here, 3 minus 7 times 0.4, it will give us the answer as 0.2 if you press your calculator. Then followed by variance. So the variance I want here is that I want variance for negative 5x. And please be aware, how to calculate this answer here is that, so regards on variance calculations in such case using properties, it's just that we focus on the coefficients of the x, we factorize out and we square it. So as a result, we have 25 when the time you square negative 5. And the variance that you find out just now, according to our calculation in part 2, 41 over 150. So when the time you multiply and simplify it, you happen to find out the answer can be written as 41 over 6. Keep it in fraction form in this case here, because this is the exact answer. It will be more accurate. Then we go for the last examples. Example number 2 for the last part here. You're given a continuous random variable, have the PDF as the following. A, find K. B, find expected value and variance. C, find expected and variance also in some other form. So I will start with the calculations on part A to find K. So this one here, we need to recall on the techniques. Whenever you have some unknown inside the function you want to find out, it's always useful to think about this formula here. Integrate from infinity to infinity for your PDF equals to 1. So with this idea here now, we will begin our calculation such that I will integrate my function from the smallest value I can see, 0, largest I can see is 2, for my function fx, and I should know that the answer is to be 1. Then I go on with my calculation, substitute the function inside. K2 minus x squared dx equals to 1. Then what I will do the next is that I would like to expand the square part before I integrate. Of course, if let's say you don't want to expand it, it's all right. But in this case here, I would like to expand it because somehow in my later calculation, I need to know the expanded functions so that my integration process will get easier. So in here, by the time I expand, I have 4 minus 4x plus x squared dx equals to 1. So in this part here, if let's say I don't want to expand the k inside, you want to expand the k inside is all right. But let's say I don't want to expand the k inside so that I doesn't create so many k for my further calculations. So I factorize out the k from the integral. So later my integration, I just focus on 4 minus 4x plus x squared only. And therefore, I have integrate 4x minus 2x squared plus x cubed over 3. Integrate from 0 to 2 equals to 1. Then go on. By the time you substitute 2 inside the function and substitute 0 inside the function, let's see what we have. We will have k bracket minus k brackets, where we begin with substitute 2 inside the function, then substitute 0 inside the function, and let's see what we have. So substitute 0 inside is very obvious. Each of the term will turn out become 0. Whereas if I substitute 2 inside, I will happen to find out that the answer equals to 8 over 3. So as a result, by the time I simplify, I find out that I have 8 over 3. Sorry. I find out that I have 8 over 3k. 8 over 3k is equals to 1. So k equals to 3 over 8. K equals to 3 over 8. This is how I get my answer. Then as a result, now we can go for the calculation for part B. And before I go on with part B, let us extract the equations here. Let me extract the equations here for further calculations. And the k, we already find out that it's happened to be 3 over 8. And take notes. Just now, this part here, we happen to find out that I can expand to become 4 minus 4x plus x squared. So now this is the functions that I want to refer. After I substitute my k, after I expand, the 2 minus x squared. Followed by, let us calculate what is the expected value, ex. So again, what is ex is that I want integrate from 0 to 2, x multiply fx. So instead of using this function, I want everything multiplied with x. So I need to multiply with x. And what I have there, if I multiply with x, so guys and girls, I will have 3 over 8x multiply 4 minus 4x plus x squared dx. So as a result, what I have now is that integrate from 0 to 2. So when the time I happen to integrate, I have it as 3 over 2x minus 3 over 2x squared plus 3 over 8x power 3 dx. When I integrate, I have it as 3 over 4x squared minus 1 over 2x cubed plus with 3 over 32 x power of 4 from 0 to 2. Then from here, as I substitute 2 for calculation, I happen to find out that I will have the answer as 1 over 2, substitute 0. So by right, the answer is just 1 over 2 itself. Okay, go on. Next, I still need the functions here. So, where is it? I still need these functions here. So let me extract it for further calculations. Where in order to calculate the variance, I need this one to help me to find out what is my EX squared. So guys and girls, to calculate out my EX squared, the next part, the variance, I need to calculate out what is EX squared. I need to multiply the function with x squared. So integrate from 0 to 2, x squared multiply fx dx. So as a result, when the time I multiply, I have 3 over 8 x squared multiply 4 minus 4x plus x squared. And the expansion, it will happen to give me the result as, so when the time I expand, 3 over 2x squared minus 3 over 2x cubed plus 3 over 8x power of 4 dx. When the time I integrate, I have 1 over 2x, 1 over 2x cubed minus 3 over 8x power of 4 plus with 3 over 40 x power of 5 from 0 to 2. Then as you substitute 2 inside the functions, you happen to find out that you have the answer as 2 over 5. Whereas when the time you substitute 0 inside, you happen to find out that your answer is minus 0. So the answer is just 2 over 5 at the end. Because you substitute 0 inside, you got it as minus 0. So as a result, your final answer is 2 over 5. And of course, this is not any of the answer. Please always alert. The calculation here is actually calculate for EX squared. What you need is variance. Again, how you calculate variance. Variance is actually referring to EX squared minus the square of expected value. So as a result, I have 2 over 5 minus 1 over 2 squared. And this will give me the answer as 3 over 20. Of course, you can keep this answer in decimal because the answer is equal to 0.15, the exact value in decimal. Lastly, part C. I would like to find out what is my EY and also my EX, where EY is equal to E. The Y is referring to 3x minus 5. And in order to get this answer here, I need to make use of my EX answer, where my EX answer from the previous part is happen to be 1 over 2. So how to get this answer here? By using properties, 3EX minus 5. So 3 times 1 over 2 minus 5 will be our result. So in this case here, what I will happen to have is that I have negative 7 over 2. Then lastly, variance of y. Variance of y is actually variance for 3x minus 5. And in order to get this answer, I need to refer to my variance x, which is happen to be 3 over 20, not 2 over 5, 3 over 20. So now we calculate by using properties. I have 3 square multiply variance x. The constant minus 5 is ignore here because it will equal to 0. So as a result, I have my answer as 9 multiply 3 over 20. And as a result, I will have 27 over 20. And then that's it for our last question on chapter 9. Then for the coming Monday, we will go on further with chapter 10. So I hope that you get ready with your statistical table and also your lecture notes. So we start with binomial distributions. That's all for today. Thank you very much for watching.